Now let's make a polynomial when we are given the zeros for it. So when we have the zeros -3 and 5, we get them originally from when it was x plus 3 and x minus 5. And that would be equal to 0, and that would give us, if we multiplied it out, x squared minus 2 minus, let's say, minus 5 and plus 3 minus 2x minus 15 is equal to 0. So that would be a function. And we could even say the function of x is that. However, we are also given this information, that at 2, or when x is 2, that the result is -45, that the function is -45. So what we have to do is to account for that. So here's how we're going to do it. And there are actually two methods for doing this. So one of the methods, I am going to do two methods for it. Doesn't matter whether you call it method 1 or 2. I'm just going to call this one 1. As I'm going to take this part here, the function of x is equal to, and I'm going to say it's a times x plus 3, x minus 5. Because sometimes there's a coefficient. You get something like 7x squared and so on. Well, we need to know what that number is if there is one. It might be that it's only 1. If it is only 1, then we will use that. Okay, so right now, though, we also know that the function at 2, if that's 2, would be equal to -45. That's essentially saying that there's a point on the graph where at 2, the x is 2 and the y is -45. Interesting. So it's a parabola, and at 2, it's way down, way low in the y values for the y. So I could say f of 2 is equal to a 2 plus 3 and 2 minus 5. However, I don't have anything over here for them to solve. So it's actually better to use the -45 is equal to a 2 plus 3, 2 minus 5. And now we have something we can solve. We can solve for the a. That -45 is equal to a times 5 times -3. So -45 is equal to -15a. Divide by that, a is equal to 3. So if a is equal to 3, I can now put that back into here. Okay, and I would multiply it out. So the function of x is equal to 3 times x squared minus 2x minus 15, which means that it's 3x squared minus 6x minus 45. Well, now let's do the other one. Okay, so I get here, and I could draw a line. Whoops. Draw a line along here. That to be a straighter line. We're going to do this again on another one in just a second. I'm going to do this as a nice, neat f of x equals 3x squared minus 6x minus 45. Let's do this slightly differently, and we should get the same result. Okay. So in this case now, over here, I'm going to call this one method 2. Method 2, I multiply these out just as I did here. And then I do -45. Oh, wait a minute, before that, I need to recognize that this is f of x equals a times x squared minus 2x minus 15. So I'm going to have to put that a there. But now I know that -45 equals a, and let's put the 2 into these. 2 squared minus 2 times 2 minus 15. -45 equals a. That's 4 minus 4 minus 15. Oh, good. The 4's cancel out. So -45 equals -15a. Oh, we get the same thing. A is 3. And then when we put 3 back into it, okay, the function of x is equal to 3 times x squared minus 2x. It looks like we're getting the exact same thing that we did a moment ago. either way that you do it, you're going to get the same one. The difference in them is that here you don't multiply out those yet. Here you do multiply them out. You end up having to multiply them at the end no matter what. So down here, you'd end up having to multiply. Your choice, just as long as you're careful with your numbers. Now, let's look at a different one. And here, there is something special going on. We have an I. We have an imaginary number. We know that for this one, we're going to have an x minus 2, because we use opposite sign, and we have x minus I, which we know is the square root of negative 1. But what you also need to know is that i's, or imaginary numbers, come in pairs, or complex numbers. We have a complex number too. Complex numbers are in pairs. Have I, you also have negative I. So if you have I, you also have negative I. So what we have here is x minus 2 and x minus, not quite placed how I want, x minus I, and then x minus a negative I, which means that that's x plus I. So I'm literally going to erase that and change it so it's x plus I. So that's what we have now. Okay. And that's very important for us to look at. The problem we have here is that the method 1, oh, by the way, back to here for a moment, this is called conjugates. This is a conjugate. You already have heard that, you just might have forgotten that word, so now I'll bring it back to mind. So the problem we have here right now is if I do f of x equals a, x minus 2, x minus I, x plus I. Now, I'm going to write this and then erase it because it shows it's not going to be an easy way to do it. If I do negative 40 equals a, negative 2 minus 2, that would work, but negative 2 minus I and negative 2 plus I, well, now what do I do? Those don't just simply add up to a simple number. Now I've got to do some multiplying out anyway. So in this case, I'm going to choose to do it more in the method 2 way, where I'm going to multiply out these, but I'm going to do it where I'm going to do these two first. And the reason for that is because when you have 1 minus and 1 negative, I have an a squared minus b squared system thing, a difference of two squares, which means if I have a minus b and a plus b, then when I multiply it, the middle terms go away. Watch this happen and you'll see it. F of x is equal to a, x minus 2, which we're holding off now. X times x is x squared, plus ix, minus ix, minus I squared. So here at this point, notice these two will cancel. So I have that the function of x is equal to a, x minus 2, x squared minus I squared. Now we have something we can work with because I squared equals negative 1. So I can do function of x. Okay, let's just continue here. X squared minus a negative 1. And although most people would not write it, would have just made it plus, then I want to show this step going to that, plus 1. All right. Now I will multiply the x minus 2 into that. So x times x squared, x times 1, negative 2 times x squared. So actually it's x to the third minus 2x squared. Let's see, plus 1x. So I'm trying to make sure I put these in order by exponent first. Okay, now that I've got this, because of the fact that I had to do out this part, all of this, which I didn't have to do in the above example, but by doing that, now I have something I can work with where I can now use this, that the function at negative 2 is negative 140. I'm going to put that one in black. So the result is negative 140 when the x value is negative 2. Okay, so let's make sure I put these in all the right places. -2 and -2 and -2. Okay, so it gives me -140 is equal to A. Well, -2 to the third is a -8. -2 squared is a 4 times -2 is another -8. And we have a -2 and a -2. Ooh, add up all those, 16, -2s, -4, it comes to a -20. So we have, let's make these -20 times A. And when I divide by the -20, we get that A is equal to 7. So now at this point, we can put the 7 multiplied. We have at this, where we were here, we could put 7 in and we can multiply to each of those so that the function of x is equal to 7 times the x cubed, 7, that's this one, 7 times the -2, so it's -14x squared, 7 times the 1 that's there, so it's plus 7x, okay, and 7 times the -2, so we get a -14. And so that is the polynomial that we get when, in this case, we have 2 and I as two of the three solutions for it. And the I means we also have a negative I to work with. So there are a couple of other examples here that I have. So I'm going to do these out so just as practice so people can see. Not a plus, but it's a -4. And it's an x plus 2. Okay. So I'm going to do where it's the function of x is equal to a, x minus 4 and x plus 2. And then I know -25 is the result when the x is a -1. So I'm going to put -1 into these. That's a plus 2. So -25 is equal to a -5. And 2 minus 1 looks like it's a 1. Okay. So it's going to be -25 equals -5a. So a is equal to a +5. So then that means I can come back to here, this one, and I can put the 5 in for the a. So move that over here. Function of x is equal to 5, x minus 4, x plus 2. Function of x is equal to 5, x squared, minus 4x plus 2x is minus 2x minus 8. And the function of x is equal to 5x squared minus 10x minus 40. Okay. So let's make a note about something. Not an acceptable final answer. Must be simplified. And simplified in this case means multiplied out so it looks like a polynomial function the way that this answer is. Let's do another one here with the imaginary number. Okay. So I have a 5, so that's x minus 5. And it's minus I, so it's x plus I. But then I have to use a conjugate, which would be a positive I, so I have to use the opposite sign when I put it into the extremes there. So now I get that the function of x is equal to a times x minus 5, x plus I, and x minus I. So in this case now, I'm going to have to multiply that just like I did before. X minus 5. And so I'm going to do this as it's x squared plus ix minus ix goes away, and it's negative I squared. Well, that negative I squared is equal to a -1, so it's a +1 now. So the f of x is equal to a x minus 5 x squared plus 1. I could at this point go ahead and put in this part. So I'm mindful, I can do it that way, or I don't have to, but I can. So I'm going to say, instead of saying f minus 3, since those are equal, I I'm simply going to say that what it is, that's negative 160, is equal to A. Let's put negative 3 in here and negative 3 squared in here. Since there's no I, now it's doable mathematically. So that's a negative 8. And let's see, that's a positive 9 plus 1, which is going to give us 10. So that's negative 80. So we have negative 160 equals negative 80A. That means we have a 2. So now that we have a 2, now we can actually work out the rest of it. So the function of x is equal to 2, x minus 5. And we already figured out it's x squared plus 1. So the function of x is equal to 2. And x times x squared is x cubed minus 5x squared plus x minus 5. And then we'll multiply the 2 into it. It's 10x squared plus 2x minus 10. I still don't like it. I don't want to hit the exponents there. That 3 and 2, and I actually want that 3 to be more certain than it's a 3. Okay, I think that works. And get all that in. So those were a couple of examples showing how to do it with or without the imaginary number. So these two examples, these two good first examples, and here solving for them using the quadratic formula or by factoring. We have to start off with the rational zeros. Hopefully this helps. Thank you for watching and listening.